Okay. So we'll review another proof together. We're given that C is the midpoint of AE and BD, and we are trying to prove that ACD is congruent to ECB. So one thing that I can do, I can always put my goal there at the end. I could do this first if I want, because I know where the proof needs to finish. And what I will say too is a lot of times it's very helpful to work through in order, because then you can follow the thought process of the proof. But also you don't have to. If you see something else that you can fill in ahead of time, that could be fine too. But let's go through in order. So what would I put for number 1 where it says given? Rachel. Okay. So C is the midpoint of AE and BD. So if I know that C is the midpoint of AE, I would mark these two congruent. What would be my reason for marking those congruent? Elmer, what do you think? How do I know that AC is congruent to CE? How did I know to put those two marks right there? What's that? So the first thing I read was that C is the midpoint of AE and BD. What does a midpoint do? What's that? Putting things together? Not quite. What's special about midpoints? Jackson?
That they're like in the middle, so the two other sides are equal.
Right. Okay. So a midpoint is in the middle, which means the two things on either side are going to be equal. So if C is in the middle of AE, then that means the two things are on either side are going to be equal. And so what that is that is the definition of midpoint. Sometimes a little abbreviated definition as DEF. But again, if you follow the thought process there, I'm told it's a midpoint. That means the two pieces are congruent. That's the definition. Okay. Next, this statement says BC is congruent to something. What would BC be congruent to? CD. Okay, and how do we know that? Rachel? That's also a definition of the midpoint. Yeah, so we're told that C is the midpoint of BD, which means that the two halves will be congruent.
Are we gonna need to know the like definition of midpoint, all that? Yeah.
Mm-hmm. Which you do know the definition of a midpoint, which is that if something is a midpoint, the two sides are going to be congruent.
Well, I mean, like, going right through.
Mm-hmm. Yeah. Okay, the next one says that vertical angles are congruent. So what angles are vertical angles in that picture?
One and two.
angles 1 and 2 are vertical angles. So I can mark that on there. And then, last but not least, we have our triangle ACD is congruent to triangle ECB. What would the reason be? Rachel? Side, angle, side. Yes. Very nice. Okay. So let's look at the next one here. So we are told that HA bisects angle MAT, and we are told that angle M is congruent to angle T, and we are trying to prove that these two triangles are congruent. So what could I write first? Right.
HA bisects MAT.
Okay. HA bisects angle MAT. Okay, so here's angle MAT. That's this angle right there. And we were told that HA bisects that angle. Here's angle MAT. Turn to your partner. What does that mean? What does that mean that that angle is bisected? Okay, what does that mean that HA bisects MAT? What is that going to look like on the picture? Rachel? Yeah, it's going to split it in half evenly. So there it is right there. That means this half is going to be the same as this half. Do you guys agree? These two pieces would be the same here? Okay, so now we just want to say that. That's going to be our next statement. We're going to say that angle MAH is congruent to angle TAH. Tate, do you know what our reason would be for that? So, no, so hypotenuse leg is something that we would say for the triangles being congruent. That might be our reason for the last one. But how did we know that those two angles were the same? What told us that? Or do we just guess that those two angles are the same? Not sure. Kira, what were you thinking? Yes. So we were told, the first thing we were told was that HA bisects angle MAT. And that told us, oh, okay, bisect means it creates two congruent pieces. So what this is the definition of, and we want to say definition of an angle bisector. Now, here's something that you can write in. If you don't remember the phrase definition of angle bisector, something that you could write that I would accept is you could say like angle bisector makes two congruent angles. Or you could say like angle bisector divides it evenly. Or bisect means cut in half or something like that. Because that's how we knew. You're basically explaining here, how did we know that those two angles were congruent? The reason we knew is because the given information was that HA is bisecting MAT. So you can always just write a little sentence there and explain what you're thinking. Melanie, what is going to go next? What have we not put in yet? Okay, what if I told you that this was the next statement right there? Angle M is congruent to angle T. Do you know what the reason would be? How do we know? No, so where did I get that from? Where did it come from? Huh? Or so what do you think? From the sides? No, not from the sides. Last year? It's given. Okay, so given means that we start with this information. So it's up here, it's at the beginning of the problem. Okay, so I can mark that on the picture. Daniel, is there anything else in this picture that we could mark? Anything that we know from the picture?
Side.
Which side? Yeah, so we have a shared side right here. So we have our shared side. So we can mark that. And I'm going to say AH is congruent to, what would it be? AH. Yes. So that's how we talk about shared sides. And then what would our reason be for the shared side? What's that?
Angle bisector.
No, not angle bisector. Lassia? Definition of shared side, very close. Reflexive. Yes, this is the reflexive property. Okay, so remember the reflexive property from Unit 2? That's like when, A equals A or 5 equals 5. But we can also use it to say that AH is congruent to AH. So when something equals itself. Okay, what would our last statement be? HMA congruent to HTA. Yes. So that's our last one. And then what is the reason? How do we know the triangles are congruent? Okay. Angle, angle, side. Yes. Angle, angle, side. Okay. So, one thing that I want to show you guys, don't erase anything, but I'm going to erase some things real quick. Actually, no, I'm not going to erase them. I'm going to move them around. So, we don't have to say that HA bisects MAT first. We could have said, we could have put the other given information first. But if we do that, if I put the other given information first, I can't say this next one, MAH congruent to TAH, until I say that HA bisects MAT. So this, it would change that position a little bit. Oh no. So what I really need is I need this definition of the angle bisector to come after I say HA bisects MAT. So this needs to come before. It doesn't need to come right before. I could do it like this. This would be fine. But the main thing is that this statement needs to come after this reason. It needs to come later. And even, oops. So we have some flexibility here. I could even put this one first. I could put the shared side first as reflexive property. Oops. Oh no. So I could do my proof like this if I wanted. So there's not always one right answer. When it's blank on both sides, there's different ways that you can do it. But what's really important is this needs to go last. And in this case here, because this is talking about an angle bisector, it needs to come after the given information about the angle bisector. If you're not sure if the order that you put something in is okay, you can always ask. Okay. I want you guys to start doing this one. I want you to see how much information you can put on the picture, or on the proof here, and on the picture. And then we will finish it together. So go ahead and start that. You can work together. All right, guys. So let's take a look here. So what things do we know? What we got going on? What can we put on here, Gerald? MN is parallel to PO. How do you know that? Because the two lines, yeah. And what? So what would you put as the reason? Given. Okay. Now, also, it's not wrong. I could also put MP parallel to NO. I could put that on the same line because they're both given. It's the same reason for both. It means that I won't use 6 steps. I would just use 5 steps instead. But it's fine to do that if you want to do that. The 6 steps are written out so that it's on different lines, but you have some options. Okay, so we have our given information. Does that mean, if these lines are parallel, does that mean that MN is equal to PO? Are those the same thing, parallel and equal? No, those are not the same thing. Okay, so we do not know that these lines are are equal, but we do know that they are parallel. Here's two lines that are parallel, but they are not the same. Okay. What is some other information that we could put on this proof? Awesome.
PN is congruent
PN is congruent to
to PN.
PN. Very nice. And what would the reason be for that?
Reflexive.
Yes, the reflexive property. It's fine to just write reflexive if you want. It's also fine to write reflexive property. Jackson.
The alternate interior one.
Okay, so you're seeing some alternate interior angles. So that would be angle angle 3 and which one?
1.
And 1. Yep, and then that would be 2 and 4. Okay, so we have alternate interior angles. Here's a way, if you didn't see the alternate interior angles, what you can do is you can look for the letter Z. When you have, and you make this with parallel lines, when you do this, it's these angles that will be congruent. So we basically have two sets of parallel lines, so the other letter Z would be, it would be backwards, but it would go like this. So that would mean that those two angles would be okay. So what I'm going to write in here is angle 1 is congruent to angle 3. I could also write angle 2 is congruent to angle 4 on the same line because they have the same reason. Or I can write them on two separate lines. It's whatever one you want to do is fine. Artistic choice. Now, do you guys remember Jackson's reason for them being congruent? Kira. Sorry, what? Yes, they are alternate interior angles. Okay, so here's how we are going to write that in a proof. We're going to say that parallel lines, and then put the arrow, and then we can say alternate, I'm going to write this on two lines because I'm running out of space. Alternate interior angles are congruent.
So you wouldn't accept just alternate interior?
Yeah, that's correct. If you just write alternate interior angles, you will get some partial credit. You'll get almost full credit. But here's the reason that by itself is not enough. Is because if I have two lines that look like this, and I look at angle 1 and angle 2, are angle 1 and angle 2 alternate interior angles? Yes, they are. Are they congruent? No, they're not. Why are they not congruent? What would need to be true? Right in. The lines would have to be parallel. So yeah, we always have alternate interior angles. They always exist. But they're only congruent if the lines are parallel. If the lines aren't parallel, it's not quite true. So that's why it's important that we write. Remember, this arrow means if then. So it's saying if you have parallel lines, then alternate interior angles. It will not be very, if you can't remember that full thing, it will not be a ton of points off. But it is important that you remember why. So. What will our last statement be? Alessandro.
Triangle MNP is congruent to OPM.
Yes. Okay, and so we have angles as congruent. We have our shared side. What is our reason? Great.
Angle side angle.
Angle, side, angle. Very nice. Oops. Okay. Questions on that one? All right. Okay, so now we're going to look at some proofs using CPCTC. Does anyone remember what CPCTC stands for? Okay, this stands for corresponding. Does anyone remember the P? It's not perpendicular.
Parallel.
It's not parallel. Parts. So corresponding parts of. Does anyone know what the T stands for? Triangles, yes. So this is corresponding parts of congruent triangles. So that's relevant, right? We're talking about congruent triangles. Are what's true about corresponding parts of congruent triangles? Yeah, they're congruent. Yeah. So remember, this is what 5.1 is all about. If I know that triangle ABC is congruent to triangle DEF, then that means that angle A is congruent to angle D. Yes. So those are corresponding parts. The triangles are congruent. Therefore, A is congruent to D. So that's using corresponding parts of congruent triangles are congruent. I would also know, so same reason here. Okay, if the triangle is congruent, then AB is congruent to, segment AB is congruent to DE, exactly. Okay. So that's just saying, if the triangles are the same, all the parts are the same. So in this proof right here in number 3, do we know that the triangles are congruent? Is that given to us? No, it's not. So first, we are going to prove them congruent. So first step, prove the triangle's congruent. Then use CPCTC. Okay. So I'm going to do the given information first. ST parallel to RQ. That's there. SR congruent to RP. It's also given. And last, angle SRT is congruent to angle RPQ. Oh, that's good. Okay. So usually anytime we have parallel lines, it means that we're going to use that to prove that some angles are congruent. So here are the parallel lines. And here's the transversal. Does anyone see any angles that would be congruent because of those two parallel lines? That would help us. What's that? Okay, angle RST and angle PSQ. Actually, so the top one I can call angle S just because it's by itself if I want. And then PRQ. So the top angle of each triangle. So if I draw them separately, it kind of looks like that. What type of angles are they? Lassie? They are corresponding angles. So great job, you guys. So here's how we're going to write it. Parallel lines, arrow, corresponding angles are congruent. Okay. Who thinks they know what we're going to say next? Jackson?
It gives us the angles P, R, or SRT, RP.
Yeah, so it gave us these, the bottom ones, and then the parallel lines told us that the top ones were congruent.
We didn't put the angles.
Yeah, we did. They're right here, number 3.
Oh.
Good. Any ideas on what we're going to do next? Meg? We can prove the triangles. Okay. So it would be triangle. We could say SRT. What is triangle SRT congruent to? RPQ. Very nice. Okay, and the reason would be side on side. Okay, so here's one thing I want to point out. This arrow for parallel does not mean congruent. It just means parallel. So that one doesn't count as a side. Jackson.
Angle side.
Yes, it is angle side angle. I heard someone else say that there as well. Yes, this would be angle side. Okay, so that's right here. First, prove the triangle's congruent. Check. So now, if those triangles are congruent, is that enough information to say that RT is congruent to PQ? Yes, it is. And what would our reason be? This would be corresponding parts of congruent triangles are congruent. So that's going to be our reason. If you also said definition of congruent triangles, that would also work. This is a little quicker, CPC. So first, prove the triangle is congruent, then CPC. All right. So we've got another proof here. Again, I'm going to start with what? What am I start with? The given, yeah. P is congruent to S. So I'm going to mark those as congruent. We always want to mark the picture. Very helpful. And we're told that O is the midpoint of PS. So I'm going to abbreviate midpoint there. Hope that's okay. And that is also good. Okay. Is there a way that I can mark the picture if O is the midpoint of PS? Alessandro? Okay, yeah. Where would I put those on the picture?
PO is congruent to OS.
Nice. PO is congruent to OS. Okay. So because we marked the picture, we then want to write that down. PO is congruent to OS because that was not given information. We were told something very close to that. We were told that O is the midpoint, but we were not told that. So, Alessandro, how did you know that PO was congruent to OS?
Definition of midpoint.
Definition of midpoint. Okay. Does anyone see anything on this picture that we could talk about? Any idea what we could do next? Megan? There are vertical angles. Yes. Okay, so the vertical angles are right here. So you have two options of how you could write this. I think you're going to like the second one better. The first one, let me just show you, is ROS congruent to QOP. But what you can do, you're allowed to do this. If I put a little number 1 in there and a number 2 right there, I can save myself a little bit of writing by saying angle 1 is congruent to angle 2. So you are allowed to do this. What do you guys think? Is that better? And we're going to say, does anyone remember the reason for vertical angles?
Vertical angles are congruent.
Yes, vertical angles are congruent. Okay. I want to think big picture here. because sometimes it can be confusing to figure out what comes next. Remember, my goal is to prove that O is the midpoint of RQ. So RQ is right there. What would tell me that O is the midpoint of RQ? What would I need to know for that to be true? Last one.
Like the two sides have to be.
Yes, we would need to know that the two sides of it are equal, the two halves of it. What are the two halves of that?
RO.
Okay, so we would need to know that RO is congruent to OQ. So this is a strategy that you can use with proofs, is to work backwards. So then, what would I need to know in order to show that RO is congruent to OQ? What would tell me that? Megan? The triangles will need to be congruent. Okay. Yes. So that would be like triangle ROS is congruent to, what's congruent to ROS? RSQ. PQO, that's close. What matches with R? Q, yeah, Q goes with R, so QOP. And what is the reason? Angle, side, angle. Okay. Now that we know that the triangles are congruent, what is our reason for RO being congruent to OQ? Huh? What's our reason after the triangles are congruent? CBCTC. Okay, and then, so that tells us that those two are equal. So if they're equal, now we know that O is the midpoint because of definition of midpoint. And that's what Lassie was saying earlier, that I said, what do we need to know for O to be the midpoint? She said the two sides of it have to be. That's what I meant.